Dr. Deepthi, and we are looking at different concepts of maths under the heading Decreations Mathematics. Currently, we are looking at complex analysis, and in that, we are going to look at singularity. So, when you consider a function f of z, and if you notice that it is not analytic at a point, then that point is called a singular point or singularity of the function. For example, if you have a look at this function 1 upon z minus t, obviously when the denominator will be 0, the function is not going to be analytic, and the denominator will be 0 when z is equal to t. So we will say that this function has a singular point or a singularity at the point z is equal to t. So if I give you a question that identify the singularity of the function f of z, which is minus 5 upon z minus 3, and four alternatives are given, minus 3, minus 5, 3, minus 5 by minus 3, and you will see of course that the denominator is going to be 0 only for the case when z is equal to 3. So the correct answer has to be alternative C. Now, there are types of singularities. So let's talk about isolated singularity. If z is equal to 2 is a singularity of f of z, and if there's no other singularity in the neighborhood of the point z is equal to t. So we can also say in the delta neighborhood, where delta is of course a very small value. In that case, z is equal to t is an isolated singularity of the function. So this can also be said in other words. That is, if a point t in the domain D of a function f of z is considered, it will be known as an isolated singularity if f of z is analytic at each point in some deleted neighborhood mod of z minus t less than delta of t. So basically you're talking about delta neighborhood of t. So there it is analytic at every point except at the point t. So then it is called as isolated. So the way it has a meaning in the language, similar meaning is seen here, isolated. You don't have any company of any other singularities. So the most typical example is of the function f of z is equal to 1 by z. So here, the moment you see it, you realize that it has an isolated singular point, which is z is equal to 0. So because if you consider an open disk, so when you consider say delta neighborhood of z, then f of z is going to be analytic in mod z lying between 0 and delta. So delta obviously is positive. So 1 upon z has an isolated singularity at the point z is equal to 0. So in simple terms, had z been equal to plus 1 or z been equal to minus 1, even at these 2 points, the function was analytic. Now, there are some other examples. So, continuing the same idea, if I had given you a situation where 1 upon z minus t, that is the function, then you would have realized that t is isolated neighborhood, isolated singularity. For example, here 9 upon z plus 16. So, singularity is of course at z is equal to minus 16. Similarly, if you consider that there are two terms in the denominator, 1 upon z minus 4 into z minus 5. Now, in this case, you can see the annular region where mod of z lies between 4 and 5. And then you would say that it has isolated singularities at z is equal to 4 and z is equal to 5. So these are some typical examples of isolated singularities. There are some other types also which we'll be seeing in further videos.